Alright, hi guys. So we're going to go into another practice test here in the additional math section again. It's going to be the May, June 2022 version and version 2 of paper 2. So it's going to be a 2-hour paper, and let's get right into it because it is such a long paper. Alright, so the first question. So it tells us directly do not use a calculator in this question. So what that means is that although they really can't monitor if you're using your calculator, they will expect you to write down all your working in a way that is understandable without the calculator. So that's why write down all your working, and even if you have the right answer but you use your calculator to do it, they will give you 0 marks. So make sure it's clear that you could do it without a calculator, even if you happen to bend the rules a little bit and use it. But on the whole, you should expect to not use the calculator. So it's giving us the value of x and it's asking us to find y. So let's just substitute x in there. So we have y is equal to 6 plus root x, which is root 6 in this case, plus over 3 plus root 6. Now let's rationalize the denominator to get rid of this surd. So we have y is equal to 6 plus root 6 times 3 minus root 6 over 3 plus root 6 times 3 minus root 6. Again, remember that a positive and negative sign will cancel out the surds, and what you do to the top, you have to do to the bottom. So this is just the same number, it's just written a different way. So y has to equal 18 minus 6 root 6 plus 3 root 6 minus 6 when we distribute over 9 minus 6, which gives us 12 minus 3 root 6 over 3, which is equal to 4 minus root 6. And this is in the form that they want, so therefore our answer is 4 minus root 6, and if we were to say what A, B, and C were, A would be 4, B would be -1, and C would be 6. So moving on to the next question. So the diagram shows the graphs of y equals f of x in the absolute value function, and y equals g of x, where y equals f of x and y equals g of x are straight lines. Solve the inequality. So they haven't given us the equations of the y of these values, nor have they given us the intersection points. So the first step that we're going to do is find their equations. So let's find what f of x is first. So we're given 2 points. So this one here is 0,5, and this one here is 2.5, 0. When you substitute it into the gradient formula, you get 5 minus 0 over 0 minus 2.5, which is the same thing as -2. We know the y-intercept is 5 based on this point over here, and therefore f of x is equal to -2x plus 5. Let's find g of x. So for like f of x, we're given 2 points for g of x, so one is over here, which is 0, -1. The other is over here, which is 1, 0. So if we put this into our gradient formula, we get 0 minus -1 over 1 minus 0, which is the same thing as 1. So therefore, g of x, we also know that its y-intercept is -1 based on this point. So g of x is equal to x minus 1. Now what we want to do is equate the two. So we know that the absolute value of 2x plus 5 has to equal x minus 1 because we have to find their intersection points. So what we're going to do is we're going to find the two solutions. So there are two solutions when you have absolute values in play. One of them is when it's 2x plus 5 is equal to x minus 1. And the other is a little bit more obscure to find. It's when negative of 2x plus 5 is equal to x minus 1. And let me explain why. It's because if you negate this value, it's still going to come out positive because of the absolute value sign. So therefore, we can equate it to this here. So let's take our first solution, which is going to be equal to x is equal to -6 when you rearrange. Well, can't box that because it's not our answer. And we can check, we can just substitute it in here. So 2 times -6 is -12, plus 5 is -7, and the absolute value of 7 is 7. -7 is 7. We could even think about making the other side. So looking for the intersection points. And, oh, sorry, it's -2x plus 5 is equal to is x minus 1. My bad. So let me just solve it again. And we get 3x is equal to 6. Therefore, x is equal to 2. Okay, yes, this is the right answer now. So if we substitute back in here, we can check Checking is good. That's why I haven't seen this paper. That's why I'm just checking my answers. So negative 2 times 2 is negative 4 plus 5 is 1. 2 minus 1 is 1. Therefore, x equals 2 is indeed a solution. Let's go to our other side. So if we solve this equation, we get 2x minus 5 is equal to x minus 1. Solving it, we get x is equal to positive 4. Again, always good to check this result. So if we put 4 back into our original equation, which is this over here, we get negative 2 times 4, which is negative 8, plus 5 is 3. Plus 5 is negative 3, but then obviously the absolute value makes it 3. Then 4 minus 1 is 3, therefore x equals 2 and x equals 4 is indeed the right answers. So now what we have to do is solve the inequality. So what we can do is go back to this over here. So you know this is x equals 4, and this is x equals 2. So the inequality is asking for which points g of x is greater. And based on this, because g of x is greater in this segment over here between 2 and 4, we can say that the answer, let me just erase this, answer is 2, it's 2 greater than or equal to x, which is greater than or equal to 4. Remember that because they're asking for which points it's greater than or equal to, we have to also use greater than or equal to signs over here. All right, great. So let's go to the next question. Find the possible values of k for which the equation kx squared plus k plus 5x minus 4 is equal to 0 has real roots. All right, we're going to use the discriminant. So discriminant, if you didn't know, is known as b squared minus 4ac. If you look at the quadratic formula, that's the part under the square root. And basically it says if b squared minus 4ac is greater than 0, it has 2 real roots. B squared minus 4ac is equal to 0, then it has 1 real root. And then less than 0, it means that it has no real roots. So what we're going to do is we're going to actually assume that this has to be equal to 0. So that's a b squared minus 4ac is equal to 0. So this here is our b, this here is our c, and this here is our a. So that means that b squared, so k plus 5 squared, minus 4 times a, which is k, times c, which is negative 4, is equal to 0. So k squared plus 10k plus 25 plus 16k is equal to 0. So therefore k minus 1 times k minus 25, k plus 1 and k plus 25, it seems. Let me just check. Yeah, k plus 1 and k plus 25 is equal to 0. So k is equal to negative 1 or negative 25. However, remember that it's real roots and therefore there's an inequality about. So it doesn't have to just equal 0. It can be greater than or equal to 0. Therefore, we have to figure out which one, which way the signs go. So we know that k and negative 1 are related, but is it greater than or equal to negative 1 or less than or equal to negative 1? We can try value on either side of k just to check. So let's try with k equals 0. If k equals 0 is less than or equal to 0, that means we have to go the other way. We have to go with k is less than or equal to negative 1. So let's put 0 in there. So if we put 0 into this factored equation over here, we get 1 times 25, which is greater than 0. Therefore, k has to be greater than or equal to negative 1 in order for it to be greater than 0. Now the other solution is with negative 25. So let's substitute a value that's less than negative 25 and see what happens. If we put like negative 26 in there, we get negative 26 plus 1 is negative 25, and then negative 26 plus 25 is negative 1. So this makes it, again, a greater value, and therefore k can be less than or equal to negative 25 and still have real roots. So these are our answers. Now let's go on to the next part. Remember the inequality signs to be correct, by the way. So next part. This one is a little bit trickier, it looks like, just because it's asking us to find the approximate change in x when y increases and rather than the other way around. So what we have to do is first, based on the fact that says y increases from 4, let's find what the value of x is at that point. So let's substitute in. We get y is equal to 1. We get 4 is equal to 1 plus 2 over x plus 1 over x squared. So find the value of x. If we multiply everything by x squared to get the fraction out of the way, we get 4x squared is equal to x squared plus 2x plus 1. Rearrange, we get 3x squared minus 2x minus 1 is equal to 0. Factor, we get 3x minus 1 plus 1 is equal to 0. Therefore, x is equal to negative 1 over 3, or 1. However, it's saying that x is greater than 0. Therefore, reject, and we get x is equal to 1. All right, so we know x is equal to 1 now, but let's differentiate this function, just because they're asking us to use differentiation. So that's always a sign that you should differentiate. And they'll give you a mark for that even if you don't know what to do with that differentiation, but we'll show you how to do that afterwards. First thing with differentiation is convert this to powers. So we get y is equal to 1 plus 2x to the power of negative 1 plus x to the power of negative 2, and that makes it much easier to differentiate. So dy over dx is equal to negative 2x to the power of negative 2 minus 2x to the power of negative 3, which can be rewritten as negative 2 over x squared minus 2 over x cubed. All right, perfect. Now, we're told that x is equal to 1. So what we want to do is we want to substitute x is equal to 1 in there and see what that rate of change is. So we get, if we substitute 1 in there, we get equals negative 2 minus 2, which is equal to negative 4. So the change at x equals 1 of this function is negative 4. And obviously that this is the same point at which y is 4. So based on that, we can say, well, what we know what dy is. dy is equal to the change in y, which is 0.01. But we want to find what dx is. And given that dy over dx is equal to negative 4, we have an equation right there. So 0.01 over dx is equal to negative 4. And now we have to solve for dx. So dx is equal to 0.01 over negative 4, which is the same thing as negative 1 over 400. And that is our answer. So just think about dy and dx as actual entities and use that to solve this equation. All right. Question 5. Solve the equation 625 to the power of x cubed minus 1 over 2 over 125 x cubed is equal to 5. All right, so we can already tell based on these numbers that they're all powers of 5. So let's convert to them. So we get 625 is equal to 5 to the power of 4. 125 is equal to 5 cubed. And 5 is equal to 5 to the power of 1. So substituting that all in there, we get 5 to the power of 4, which is raised to the power of x cubed minus 1 over 2, over 5 to the power of 3, which is raised to x cubed, is equal to 5 to the power of 1. So we get 5 to the power of 2 times x cubed minus 1, which is 2x cubed minus 2, over 5 to the power of 3x cubed is equal to 5 to the power of 1. If we multiply both sides by 5 to the power of 3x cubed, we get 5 to the power of 2x cubed minus 2 is equal to 5 to the power of 3x cubed plus 1. So therefore, we can equate the powers now that we have the same base and get 2x cubed minus 2 is equal to 3x cubed plus 1. If we rearrange, we get x cubed is equal to negative 3. So x is equal to the cube root of negative 3. And if we just put this into our calculator, remember we're no longer under that non-calc question, so we can do this. Negative 3 to the power of 1/3 is negative 1.44 approximately. So that's our answer. Moving on to question 5b. On the axes, sketch the graph of y equals 4e to the power of x plus 3, showing the values of any intercepts with the coordinate axes. All right, so this question over here, it requires us to be able to use our knowledge of graph shapes. So actually e to the power of x looks something like this. So we just need to find a few key points, such as the intercepts and coordinate axes, with the coordinate axes. So the way we can find the intercept, first let's find the y-intercept, which is the easiest. Just substitute e to x is 0, we get 4e to the power of 0 plus 3, which is equal to 4 plus 3, which is 7. So at here, at 7, let's say that's 7, this here is an intercept. We can write down the coordinates, 0, 7. Now y-intercept, this over here is a little bit more complicated because let's solve this equation. So 4 times e to the power of x plus 3 has to equal 0. So 4e to the power of x is equal to negative 3 e to the power of x is equal to negative 3 over 4. And here we hit a roadblock because e to the power of x can never be a negative number. Therefore, there is no y-intercept. Now, based on that, we do know actually that e to the power of x is like asymptotic. So we know the asymptote will be 0 because it's the y-intercept, the y-intercept, because 4e to the power of x can't be anything less than 0. Therefore, the asymptote will be at y equals 3. So we can just kind of assume there's an asymptote over here, and that can inform us when drawing the graph. Now, we know the general shape. All we need to do, oops, I can't draw. That over here would be the general shape of, then we label y equals 4e to the power of x plus 3. All right, it's 2 marks, which already indicates that it isn't that much work, so that's all you really need to do. And maybe you want to draw arrows to show it continues. All right, so question 6, part A. In this question, I is a unit vector due east and j is a unit vector due north. A cyclist rides at a speed of 4 meters per second on a bearing of 15 degrees. I'm just already going to draw that bearing. So if north, bearing of 15 degrees is here. And it's a speed of 4 meters per second, so I'm just going to write that here. Write the velocity vector of the cyclist in the form xi plus yj, where x and y are constants. All right, so I'm just going to enlarge this over here. This triangle over here, I'm going to enlarge. So since this part over here is a 90-degree angle, 9 minus 15 is 75 degrees. So this angle over here is going to be 75 degrees. Now let's assume that this is the x-coordinates to the right and y-coordinates up. And this hypotenuse is going to equal to 4 because they're talking about the velocity vector, which we know is the hypotenuse because that's the direction the cyclist is actually going. So what we can do is use some trig rules. So we know that the sine of 75 is equal to the opposite over in hypotenuse, which is y over 4 in this case. And therefore, y is equal to 4 sine 75. Same thing with x, just with cosine. So we know that x over 4 is equal to cosine of 75. Therefore, x is equal to 4 times cosine of 75. So it's 2 marks again, not much work to be done, and that's what x and y are. Now let's go to the next part. So a vector of magnitude 6 on a bearing of 300 degrees is added to a vector of magnitude 2 on a bearing of 230 degrees to give a vector v. Find the magnitude and bearing of v. All right, so what we're going to do is we're going to actually figure out in terms of I and j what each vector is. So magnitude 6 and a bearing of 300. Let's just draw that scenario. So bearing of 300 is about here with the north. And that means 60 degrees is left over like this. If we're drawing a 90-degree angle from 270, which is the nearest 90-degree like factor of 360, then this is 30, and we can draw the triangle. Doesn't really matter which triangle you choose, it's just gonna change what the opposite and adjacent is, and therefore sine and cos will still remain the same. So if we take this 30-degree angle, well, it's moving x to the left and y up. So we can say that, well, it's negative x rather. So we can say that sine 30, magnitude 6 is equal to y over 6. So y is equal to 6 sine 30. And you can actually evaluate sine 30 just because it is one of the known trig values. So sine 30, if we think back to our triangle, is equal to a half. So we get y is equal to 3. And if we do cos 30, that's equal to negative x over 6. And therefore, x is equal to negative 6 cos 30. We know that cos 30 is root 3 over 2, and therefore x is equal to negative 3 root 3. All right, so we know that this vector over here is negative 3 root 3i plus 3j. Now let's think about the next vector. So that's magnitude 2 on a bearing of 230 degrees. So 230 degrees, let me just draw that. So that's north. Then 230 is about here. 230 degrees. This is 270 over here, then this is 40 degrees. So if I just enlarge this triangle, which is a little bit inverted, 40 degrees. So it's y down, and that's negative y therefore, and negative x because it's to the left. So this has a magnitude of 2, so we know that, let me just think of the equations. Yeah, so sine of 40 is equal to negative y over 2. Therefore, y is equal to negative 2 sine 40. And then cos 40 is equal to negative x over 2. So x is equal to negative 2 cos 40. So therefore, this vector is equal to negative 2 cos 40i minus 2 sine 40j. And now they're asking us to find the magnitude and bearing of the v, which is when these two vectors are added up. So when you add up these vectors, you get, so v is equal to negative 3 root 3 minus 2 cos 40 I plus 3 minus 2 sine 40 j. So the magnitude is simple enough. You just need to do Pythagorean. So you get the square root, so magnitude, mag, is equal to negative 3 root 3 minus 2 cos 40 squared plus 3 minus 2 sine 40 squared. And if we just get a calculator out to do this, because it's so 2 cos 40 is actually, so I'm just going to write this down. So square root of negative, so we just figure out what cos 40 is in so what we just do is we need to just get our calculator, and so we get negative 3 root 3 minus 2, and then cos 40 is cos 0.6983132. I'm just converting this to radians because my calculator is in radians. Then you square that. Then you add that to 3 minus, and then 2 sine of 40, which is 0.6983132. You square that. So that's equal to about 48.2085. And then if you square root that, you get 6.94. So that's about the magnitude of this function. Now what we need to do is figure out what the angle is. So we are given the magnitude, but we need to know now what the angle is. So what we can do is, it's actually 6.943. What we can do is try and sketch kind of generally what we've got going. So we know that, okay, I'm just going to reread the question a bit, Again, I'm doing this for the first time as well, so I'm just trying to still figure it out as well. Okay, right. So we do know what I and j are, so we can just kind of sketch this out. So negative 3 root 3 minus 2 cos 40 is negative 6.7. It's approximately negative 6.73. So we know that this is going to the left by negative 6.73. Let me just write that. But if you want to be specific, we can write negative 3 root 3 minus 2 cos 40. It's going to the left. Then it goes up by 3 minus 2 root 2 sine 40, which is a positive value. So I'm actually going to move this below and then draw this going up by 3 minus 2 sine 40. And then we've got an angle going over here that we need to figure out. So we know that the tangent we have to figure out the tangent of negative 3 minus 2 sine 40 over negative 3 root 3 minus 2 cos 40. So we need to find the tangent of that first. So let me do that right now. So we have tan of 3 minus 2 sine over negative 3 root 3 minus 2 all right, and we get tan we get negative 14.9239 degrees. So if we think about it that way, negative 14.9239 degrees. And if we label this right now, negative 14.92, I'm going to put negative 14.92. So this here, if we convert it to a bearing, is that angle plus this over here. And since this right angle over here is 270 degrees basically. So therefore the magnitude, not the magnitude, what's it asking for? The bearing is equal to 270 plus 14.92, which is equal to 284.92, which is equal to 285. All bearings have to be a whole number, so therefore it's 285. And that's how we calculate the magnitude and the bearing. Moving on to the next question. So question 7, differentiate y equals e to the power 4x over times tan x over ln x. So we're going to use quotient rule. So let's let u equal e to the power 4x times tan x. And let's differentiate that. So du over dx is going to be equal to 4e to the power of 4x tan x plus e to the power of 4x secant squared x, using the product rule. Then we have, on the other hand, we have v is equal to ln x. So dv over dx, which is the derivative of that, is equal to 1 over x. So now let's substitute into the quotient rule. So first thing we have to do is put the derivative of du in. So you get 4e to the power of 4x tan x plus e to the power of 4x secant squared x times v, which is ln x, minus the derivative of v, which is 1 over x, times u, which is e to the power of 4x tan x, over v squared, which is ln x squared. If you simplify that down, we get 4e to the power of 4x tan x ln x plus e to the power of 4x secant squared x ln x minus e to the power of 4x tan x over x over ln x all squared. So if we want to make everything one fraction, we get 4x e to the power of 4x tan x ln x plus x e to the power of 4x secant squared x ln x minus e to the power of 4x tan x over x times ln x squared. Then here you can simplify it down further by actually factoring out e to the power of 4x, but you don't really need to. You can leave it like this, or an equivalent form. So this kind of question over here, it can get really, really messy, but honestly, it's not a big deal as long as you've got the right terms in there. So something like that is pretty much okay. All right, let's move on to the next question, which is this over here. So the function f is defined by f of x equals 3 sine squared x minus 2 cos x. Find the x-coordinate of the stationary point in the curve, y equals fx. So the stationary point already indicates that we're going to have to differentiate. So what we're going to do is we're going to first figure out what the derivative of sine squared x is, since that's a little bit more complicated. So sine squared x, we know, is the same as sine x times sine x, and therefore we can use the product rule. So differentiating it gives us sine x times the derivative of sine x, which is cos x, plus the derivative of sine x, which is cos x, times sine x. Because it's the same thing, they will give the same two parts. And therefore, this is equal to 2 sine x cos x. So when substituting it in, so the derivative of f of x is going to equal 3 times 2 sine x cos x minus 2 times minus sine x, so minus 2 sine x, because cos differentiates into negative sine. And this gives us 6 sine x cos x plus 2 sine x. So now we have to set this to 0, because that's how you find the stationary point. Then if you factor out 2 sine x to make this easier, get 2 sine x times 3 cos x plus 1 is equal to 0. So you have two equations. So 2 sine x equals 0 is your first one. The other one is 3 cos x plus 1 is equal to 0. So let's start with the sine x one. So sine x has to equal 0 if we divide both sides by 2. Therefore, x is equal to 0, pi, 2 pi, etc. However, 0 and 2 pi are both not in the domain. Therefore, the value has to be x equals pi. So that's one solution, because x equals pi does fall in the domain 2 to 4. But let's see if there are any more solutions. Let's check. So 3 cos x plus 1 equals 0 could yield another solution. So we get 3 cos x is equal to negative 1. Cos x is equal to negative 1 over 3. So x is the inverse of cos. Let me just check what that is. So inverse of negative 1 over 3 gives us 1.91, which again misses the domain, but maybe the other solution will. The other solution is, because cos is in the fourth quadrant, 2 pi minus 1.91 is the other solution. So let's just try that. Minus 1.91. This gives 4.37. So as you can see, all of these solutions are out of the domain, so therefore none of them are valid. The only valid solution is x equals pi, and therefore, because they've also indicated that there is only one stationary point, because they've said stationary point, not points, and this already just checked that indeed x equals pi is the only solution. All right, so part B, solve the equation f of x equals 1 minus 3 cos x. So f of x, we know, is 3 sine squared x minus 2 cos x. So 3 sine squared x minus 2 cos x is now equal to 1 minus 3 cos x. We can change the sine squared x to cos squared x in order to make sure that there's only one trig function there. So sine squared x is equal to 1 minus cos squared x. So let's do that. Minus 2 cos x. Bring these to the one side. Minus 1 plus 3 cos x equals 0. We're just trying to get it into a quadratic form. So we get 3 minus 3 cos squared x minus 2 cos x minus 1 plus 3 cos x is equal to 0. Therefore, negative 3 cos squared x plus cos x plus 2 is equal to 0. I don't like the negative sign, so I'm going to change them all. I'm going to divide everything by negative 1 to get 3 cos squared x minus cos x minus 2 is equal to 0. If we factor out, we get 3 cos x on one part, cos x on the other. This becomes negative 1 plus 2 is equal to 0. So now we have two equations again. So the first one's cos x minus 1 is equal to 0. Cos x is equal to 1. Again, we're trying to look for values in the domain 2 to 4. So therefore, cos is equal to pi over 2 or 3 pi over 2. No, 3 pi over 2 would not get the solution. It would be pi over 2 or further values. However, it's important to also consider whether pi over 2 is indeed in the domain. Pi over 2, let's put this in our calculator, which is equal to 1.57. Therefore, this is invalid because it is not between 2 and 4. The other equation might work though. So 3 cos x plus 2 is equal to 0. So cos x is equal to negative 2 over 3. If we find the inverse of that to see what x is, let's do that right now. So cos of negative 2 over 3, the inverse of cos of negative 2 over 3. My apologies. Negative 2 over 3. So that's equal to 2.3. However, 2 pi minus this could also be a solution, so let's try. 2 pi minus 2.30 rather, is 3.98. And therefore, both these solutions are valid. So x equals 2.30 or 3.98. All right, now let's move on to the next problem, given that we have got this one. So question 9. So in this question, all lengths are in centimeters. The diagram shows a circle, center O, radius A. The lines PT and QT are tangents to the circle at P and Q respectively. Angle POQ is 5 radians. In the case where the area of the sector OPQ is equal to the area of the shaded region, show that tan phi equals 2 phi. So it's saying that the sector OPQ, so I'm just going to call that, I'll call that A1, is equal to A2, which is the shaded region. Show that tan of phi is equal to 2 phi. All right, so I'm going to find the area of A1 first, given that that one's really easy to find. So A1, we know that the radius is A, and the angle is 2 phi. And given that the area of a sector is half theta r squared, when theta is in radians, we have half times theta, which is 2 phi, times r squared, which is A in this case, which gives us phi a squared as our answer. But since A2 is the same, we can say that we can also say that A2 is equal to phi a squared. We know now that the entire area of A of OPQT, that entire area, because it's equal to A1 plus A2, therefore that's equal to 2 phi a squared. Now what I'm going to do, since we can't calculate the area, I'm just going to actually minimize this first. I'm going to actually divide this in two to make right angle triangles, because we know the angle of the tangent of the circle is 90 degrees, and therefore it's just much easier to work with 90-degree angles. Therefore, this part over here is phi, and this part over here is phi, since 2 phi gets split in half. Now, it's asking us to show that tan phi, which we've already gotten actually, phi, is equal to 2 phi. So tan phi, if we use this one, for example, this is the opposite, QT is the opposite, and OQ is the adjacent. So we can say that tan phi is equal to QT over A. And we know that, let's just think about this for a second. Let me see. Right, so we know that A of OPQT is 2 phi A squared. Given that we just split OPQT in half, we know that A of half of the area of OPQT must be equal to phi A squared. And now, if we just think about this, right, let's try and figure out what QT is equal to. So let's assume that we know the area of a triangle with a 90-degree angle is half base times height. We know that OQ, which is the height, is A. So we need to know what the base is, which is we can denote as QT. So half times A times B is equal to phi A squared. So we know that half B, we can just cancel out 1A, is equal to phi A. And therefore, B is equal to 2 phi A. Now what we can do is we can substitute this into our value. So B is equal to QT, so we can substitute this in here to get tan phi is equal to 2 phi A over A. Cancels out the A's, and we get 2 phi as our answer, as required. So therefore, we were able to prove our part A. Let's go to part B. So in this case, when the perimeter of the sector OPQ is equal to half the perimeter of the shaded region, find an expression for tan phi in terms of phi. So when the perimeter of the sector OPQ, so OPQ is, okay, so I'm just gonna label this OPQ. Well, we actually know, we can say OPQ is equal to P of OPQ. No, not P of OPQ. I can just put arc. I'll denote it as arc. So OPQ's arc, we know that that actually is equal to the radius times the angle, which is 2 phi alpha. So perimeter of OPQ, given that we know that it's equal to the arc plus the 2 times the radius, which is equal to 2 phi alpha plus A plus A, not alpha, sorry, A, which is equal to 2 phi A plus 2A. So that's the perimeter of OPQ. And that's half the perimeter of the shaded region. So perimeter of the shaded region, okay, so we know that the perimeter of the shaded region includes the arc. So let me just write that down. P shaded equals arc plus, and this is the length of the 2 tangents. And we know the tangents are equal to 2 phi alpha. So we know that's equal to plus 2 times tangents, which is equal to 2 phi alpha plus, seems that the tangents are the exact same length, so 2 phi alpha plus 2 phi, not alpha, sorry, A, which is 6 phi A. So we know that perimeter of the sector OPQ is equal to half. So that means that 2 phi A plus 2A has to be half of 6 phi A, which is 3 phi A. Therefore, phi A is equal to 2A, and phi is equal to 2. So we got that phi is equal to 2. So they're asking us to find an expression for tan phi in terms of phi. So given that we were just told tan phi is 2 phi, we can say that tan phi, oh no, it's a different scenario, so we can't actually use that same thing. So let me just erase A2, A1. Oops. So let's see how we can get tan phi. Tan phi Oh, that means that we can't use that tangent information. So actually this is wrong. Let me just erase this. My apologies. Let me just try and figure out how can we get the length of... Well, we know that P of shaded is 2 times OBQ, so it's 2 times 2 phi A plus 2A, which is 4 phi A plus 4A. We also know that the arc length is included, so we can just say, let's let the tangents, equal, let's let them equal x. So we know that because the perimeter of the shaded region is 2 times the tangent plus the arc. So therefore, the 2 times the tangent plus arc, so arc is 2 phi A. So we know that 2 phi A, getting a bit tired of saying 2 phi A, plus 2x is equal to 4 phi A plus 4A. So we know that 2 phi A plus 4A is equal to 2x. Therefore, x is equal to, divide by 2 both sides, we get phi A plus 2A. So now what we can do is set up our tangent equation. So tan is equal to, well, the tangent length, which I actually named x again, my apologies, divided by A. So tan phi is equal to x over A, which is equal to phi A plus 2A over A. And conveniently, that gets rid of the A. So it's asking us in terms of phi, so that gets rid of the A's. So phi plus 2 is our solution for the expression of tan.